Hello, these are solutions to the Year 9 revision sheet on similar triangles. So what we're going to do is go through these solutions. So question 1, for each of the following state whether the transformation from A to B is an enlargement or a reduction. So in figure 1, A here is bigger than B, so B is going to be a reduction. And number 2, A is smaller than B, so it's going to be an enlargement. So that is answers for question 1. Question 2, find the scale factor of the enlargement or the reduction from A to A dash. So what we're just going to do is choose two sides because we're told there's similar figures already. So up here we've got 3 squares by 3 squares. And so on this one we find the same sides here, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 9 squares, and up here we've got 1, 2, 3, 4, 5, 6, 7, 9 squares. And so we've got 9 there. And so therefore we're going 9 over 3. That gets me the answer of 3. So it's an enlargement of 3. So B, again, I'm just going to choose two sides because we're told it's already there. So this one here, we've got, this is A dash, and that's 2 by 2, and A is going to be 3 by 3. So we go, remember, we go A over A dash. That's going to be 3, see? My mistake. A dash over A, and that's going to be 2 over 3. You need to find out how you're going to reduce. So this is reduction, so we should have a number less than 1. I apologise for that. Where part A was an enlargement, so we should have a number larger than 1. Next one, circles. Circles is easiest doing by diameter. So that bit and that bit. So we've got 1, 2, 3 circles there. 1, 2, 3, 4, 5 there. So we're going to have A dash over A. So that's going to be 5 over 3. That is a number bigger than 1. So that's what we're looking for. Next, we're looking at here, find two spaces which are the same. And we've got, let's go, hard to see on my diagram, but when you actually do the calculations, you'll find that the answer comes out as 3. I apologise, it's very hard to read on my diagram of the squares. The answer for that one is 3. So question 4, what is the scale factor in figure 2 if it's going back? So when we're going backwards, we're just doing the opposite. The first one was 3, so going the opposite direction is going to be 1 over 3. The second one, we had 2 over 3, so going backwards is going to be 3 over 2. Third one, we had 5 over 3, so it's going to be 3 over 5. And the fourth one, we had 3, and so again, going backwards, we turn it upside down, so that's going to be 1 over 3. Question 4. Parallelogram A dash is a reduction of parallelogram A. Use a ruler to measure the lengths. So, and hence find the scale factor. So, with a ruler on your sheet of paper, you would have found that the long side was on A was 25. A dash was 25 over A, which was 40. So if we simplify that, it's going to be 10. The other one was 10 over 16. So the long sides here was 25 over 40. The shorter sides was 10 over 16. So that gives me a scale factor of 5 over 8. So therefore our scale factor K is 5 over 8. Getting our protractors out, we have two sets of angles which are the same size. So the first set of angles are going to be 60 degrees, and the second set of angles are going to be 120 degrees. Next one. So now we're on to the similar figures in 16b. So question 1. Determine whether the following pairs of figures are similar. So remember, we need to go through our process. So we've got a number of different things we can use if all the sides are in the same ratio or all the angles are equal. So in this case, we're going to use to see if all the sides are in the same ratio. We need to look at doing the same sides on the same side. So the first side is going to be 8 over 6. I'm going to do the bigger triangle over the small triangle. So 8 over 6 is going to give me 4 over 3. The second one there then gives me 6 over 4. And that gives me 3 over 2. Sides are not in ratio, therefore not similar. So they're not similar because the sides are not in the same ratio. So the second one, we do the same thing. I'm going to do, start off with these sides. So it's going to be 6 over 10. So that equals 3 over 5. And then I look at the second sides here. So I'm going to do this one over this one. So it's 15 over 25. Divide them both by 5. We get 3 over 5. Sides, unit ratio, therefore similar. Question 2 of the 16b. So comment on the statement. All rhombuses are similar. If the statement is false, justify your answer. So something we know about rhombus. All sides, same length. Okay, so all sides are the same length. Therefore, sides, unit ratio. So that that's the first part of that statement is true. So we know the sides. So let's have a look at the angles. So if I draw a rhombus like that, see, let's draw a rhombus. If I draw a rhombus like that, so all my sides here, same length. And I draw a rhombus like that. So all my sides here are the same length. Angle alpha here, alpha 1, and this will be alpha 2. Alpha 1 does not equal alpha 2. So in that case, therefore, not all rhombi are similar. The only case where the rhombi are similar is when we've got a square, and that's because all the angles are equal. So question 3. We need to find the unknown in these cases. Find x given the figures are similar. So whenever we do this, remember I've talked about putting x on the top line. So there's my x, so that's going to be x on the top line. There's my equivalent side over there, so 7.5. And then we're going to do the same on the other side, so that's going to be 8 over 3. So we're going to simplify that, 8 times 7.5 over 3. And when we work out the answer, we find out that we have got 20 centimetres as our x. Part B, we need to find out with angles. So in this first triangle, we need to work out this third angle. So that's going to be 360. Take away 100. Take 75. Take 70. And that's going to equal 115 degrees if we do that. So therefore, x equals 115. Because all the angles in a similar figures are the same. Next question, we need to find out x in this case. We're told the figures are similar, so this side and this side are going to be similar. This side and this side are going to be similar. So what we have here then is x over 40 equals 10.25 over 41. So x equals 10.25 times by 40 over 41, and we get out the answer being x equals 10 kilometres. If we put in our calculator, part C. Oh no, that I'm reading my answers wrong. Triangles ABC and XYZ are similar. Find the lengths of YZ. So we're going through the same process as before. We find that AC is similar to XZ, and here CB is going to be similar to ZY. I'm going to call that X, so it's going to be X over 2.7. 2.7 equals 1.8 over 1.35. So X equals 1.8 times 2.7 over 1.35. So that equals, if we do the calculation, 3.6 meters. Next one, show that the following figures possess similar triangles. So here we need to do a couple of things. Remember, we need to look at what hits us in the face. So the first thing I see here is this angle up the top here, and I'm going to call that alpha. So actually I'm not going to call that alpha, I'm going to use alpha later on. Angle A is common, and that's given to us. And then we can just say alpha 1, alpha 2. We've got parallel lines, so alpha 1 equals alpha 2 corresponding. Therefore, triangle AEB and triangle ABC are similar. Don't forget, the order you label the triangles in is important. Next. Yep, that's cool. Next, B. We need to have a look at this one. The first thing that hits me there is angle F equals angle J equals 48 degrees, and that's given. And then we have, again, alpha 1, alpha 2. So alpha 1 equals alpha 2, y, vertically opposite. They're vertically opposite. So, therefore, triangle FHG and triangle JHI are similar. Next one, we've got the same sort of process, except this time we're given sides. You don't need to do this, just for this one here, you need to use Pythag. That's actually right correctly. Pythagoras is needed. So don't need to do. So we can leave that one out. Those who are interested, I'll show you the answer to that one later. Question 2, for the following cases, establish a pair of triangles are similar and then hence find x. So what we need to have a look at here is what's there. The first thing I'm going to do is label here alpha 1, alpha 2. I'm also going to label my triangles A, B, C, D, E. Why? Just labeling my triangles so that I know what's going on there. So alpha 1 equals alpha 2, y, they're vertically opposite. And then we look at here. Here we've got parallel lines. So therefore, beta 1 and beta 2. Got beta 1 equals beta 2, and that's because they're alternate angles. That's alternate angles. Therefore, triangle ABC and triangle E, D, C are similar. And we go to and work out the sides. So here we're going to say that we've got, here's my unknown, so AC over AB. I'm going to change that AC to be CA, just so it matches on my labelling here, so it's CA, so that one there. Oh, well, I've got AB there. So I need to work out a similar one on the other side, so that's going to be CE. It's going to be this one here, that's CE. That is equal to, so the other one we look at is where we've got the other writing, and so we've got a note there and there, so that's going to be that one and that one. That's going to be AB over ED. So when we substitute in, we get X over 3 equals AB, which is 12 over 8, I'm pretty sure that is. So look, sorry, my right board is a bit unclear, I've got to look it up. Yep, 8. So X equals 12 times 3 over 8. So X equals 4.5. And we need to put the units in there, meters. Question 2b. That's all we need to find. The first thing that hits me there is, again, I'm going to label my triangle. A, B, C, D, E. Angle B equals angle D equals 90 degrees. That's given. And therefore we can say that we can call that alpha 1, alpha 2, alpha 1 equals alpha 2, and they are vertically opposite. Therefore, triangle A, B, C, and triangle E, D, C are similar. And so therefore we can now calculate our sides. So that's the one I want. That's equivalent to that one. And then that's the other side mentioned, and that's got equivalent to that one. So we're going to have D, ED over AD, and that's equal to, that's going to be DC over BC. And then we'll be substitute in, that's going to be X over 14 equals 44 over 8. So X equals 44 times 14 over 8. So X is going to be equal to 77. And the answer is in millimeters. So C, again, labelling my triangle. A, B, C, D, E. So we can say here, angle A is common. So angle A is common. That's given to us. Then we need to look at another two. We've got parallel line there, so we can go alpha 1, alpha 2. Alpha 1 equals alpha 2 to get corresponding. To get corresponding angles. So now we can start, let's say, therefore, triangle A, B, C, and triangle A, D, E are similar. We now look at our sides. So there, we'll find that bit. So what we need to use is all of that initially. And then we've also got that. So that's going to be AB over AD. And the other side we're going to use is that one and that one. So that's going to be BC over DE. E. So now we're going to do our sides. In fact, I'm going to flip this on its head because I want to get X and I want X to be on the top line. So I'm actually going to do AD over AB. So it's exactly the same as what I wrote, except I'm just swapping them over. So that means DE over BC. So now we've got AD, which is X plus 9 over 9, so in the brackets there, and that equals DE, which is 15 over 12. So I've got a bit of algebra to do here. So X plus 9 equals 15 times 9 over 12. So X equals, the answer for that, 15 times 9 over 12, take 9. So putting all that into the calculator, and we find the answer is 2.25 centimeters. That's C. And part D, what we can't quite see here is alpha and alpha. Both two sides being both the same size, so that's the first thing that hits me, is that alpha, let's label them, A, B, C, D, E. So alpha, let's do this properly. Angle B equals angle E equals alpha. That's given. That's the first thing we can see on that one. And the next one there is at our angle A. It's common. And that's also given. So we've got those two. Therefore, triangle A, B, C, and triangle, now it's again, so A, E, see, because here we went from common angle to alpha, so here we need to go to common angle to alpha. Similar. So now we're going to look at our sides, and so we've got here AC is what we want to work out in this one, so that's, or CA, and so that means it's going to be this one here, which is going to be DA. And if we highlight the other side there, we've got this one and this one, which are BC and ED. Our unknown is AC, so I'm going to put that on the top line, so let's do that in blue because that's what I've written it on the triangle. AC over AD equals, and in red we've got BC over DE. So when we substitute in, we're going to have X over 18 equals 14 over 21. So X equals 14 times 18 over 21. So X equals 12 centimeters. Doing the problem solving questions. So here we're looking at similar triangles again. First thing we notice is that A, B, C, D, E, and F. Angle C equals angle F equals 90 degrees, given. And the other one, which is not so obvious, angle A and angle D are common. Not as easy to see there, but they're actually common angles. So therefore, triangle A, B, C, and triangle D, E, F are similar. So that's similar, and so what we want to do here is go that bit and that bit, that bit and that bit. So that's going to be X are unknown. So we're going to have EF over BC equals DF over AC. So here that means it's going to give us X over 1 equals 20.4 over 3.4. So x equals 6 meters. The height of the tree is 6 meters. Hannah is standing by a vertical wall 5 meters high, so let's draw a wall 5 meters, which is casting a shadow, a 6.8 meter shadow. So going out here vertically, 6.8 meters. Hannah is 175 meters tall, so Hannah is here, and that's going to be 1.75 meters. How far away from the wall can she stand? So we want to find this distance here, x, we want to find that x when she's basically getting that triangle. So let's label our triangle: A, B, C, D, E. Let's look at our triangles. Angle A is common. Put a right angle there, so angle C and angle E equal 90 degrees. That's 90 degrees, and that's given. Therefore, triangle A, B, C, and triangle A, D, E are similar. So now what we need to do is we need to get our bits that we want. So x is here, so it's going to be AE, that's going to be over AC, and that's going to be equal to DE over BC. So we're going to have that little bit there, it's actually going to be, to work out this bit's here, we're going to have 6.8 take x over 6.8 equals DE, which is going to be 5 over 1.75. So then we have 6.8 take x equals 5 times 6.8 over 1.75. So negative x equals 5 times 6.8 over 1.75 times, not times by, take away 6.8, and x is going to be equal to 4.42 meters. Now it's at Hannah, and stand 4.2 meters, 4.42 meters out from the wall. Next one, that is as far as I'm going to be able to go today. If you go up to questions 3 and 4, you can see Mr. Bastian. Thank you very much.